Hi, this is Mr. Gillum, and today we're looking at multiplying and dividing decimals. This is your independent practice on page 100. If you haven't tried this already on your own without the answer key, I want you to do that first, and then watch this to check your answers. It says in 1892, a world record was set. France walked on stilts. This guy, Francis Garrissoian, I don't know how to say that. There's this guy in France that walked on stilts for 4.97 miles from Bayonne to Biarritz, France, at an average speed of 7.10 miles per hour. How long did it take him to walk that distance? Well, I know that if he walked for about 5 miles, and he could walk about 7 miles in 1 hour, then I know that he was definitely walking for less than an hour. So I know for sure that choice A and choice B are out. I know that my solution should be less than 1 hour because in 1 hour he could walk 7 miles, but he only made it 5 miles. I hope that makes sense. So when I think of it that way, I think of, okay, well, in that case, I definitely need to divide 4.97 by 7.10 to find how long it took him to walk that distance. If we're talking about how long, it's kind of confusing because long sounds like a distance, but how long is actually referring to time. I know that if he had walked a whole hour, it would be 7. He would have walked 100%, or 7.10 of the entire of 1 hour. So I know that he didn't walk the entire time, so he only walked a fraction of the time, 4.97 of the 7 and 10 hundredths. So I know that I can divide 4.97 by 7.10 because that represents the fraction of an hour that he walked. If it was a full hour, again, it would be 7.10. It was not a full hour, so I want to know the fraction of an hour that he walked. So 4.97 over 7.10 would be the way to go. When I divide that, even though 4.97 is smaller, it's still going to go, it's still the dividend. It's always top divided by bottom. So I need to make sure that my decimal is in the correct place. I'm going to multiply that by 100 and multiply this by 100. There's my new decimal place. 710 does not go into 497. We knew that was going to happen. That's why we crossed out choice A and choice B. We knew it would be less than 1. So I'm going to put my 0 there, and I think we're just going to get lucky here. And if I take 710 times 7, I get 4,970. So because I was looking at this entire part here, I'm going to put the 7 above. There is no remainder. So I know that 0.7 or 7/10 would be the correct choice, which is indicated on number 1 by circling answer C. Number 2 says that Maria walks a round trip of 7.5 miles to school every day. How many miles will she walk in 4.5 days? So if she walks, well, we could estimate this one, I guess. 3/4 of a mile to school and back every day. How many miles she walk in 4.5 days? Well, when I think of 0.75 or 3/4, I think of quarters, and I know that quarters are easy for me to add up. So if I estimated that this is about 4 days, and I estimated that this is about 1, then I could say, okay, well, she's probably going to walk about a mile a day. But that's not really accurate because I rounded 1 down, 1 up. But it's pretty accurate. Like, I know it's going to be around 4. I know it's not going to be 300. She didn't walk 337 miles in 1 day. And she definitely didn't walk 33 miles in 1 day if she only walked for 4.5 days. I know she didn't walk hardly at all because in 1 day she can walk more than that. So really there's only one choice or one option that makes sense, which is B, 375 thousandths miles. That's the only really logical choice to pick, to be honest with you. So you could probably get that answer without doing any work. However, I will go ahead and multiply because that's what we're going to try to practice with. And I will figure out how long or how far that she actually walks. Now, because that 5 was at the end, I started writing my addition, my parts of sums at the end. And now we're moving over as a spot we're going to start putting our numbers there. So if you like the placeholder 0, you can go ahead and put that in there as well. It looks to me like we have 1, 2 decimal places here, and 1 there. Together that makes 3. And so you can see that we get the same solution. The book does 3 and 375 thousandths miles is how far that she would walk in 4.5 days. Number 3 says that Micah babysat for the Tylers for 3.5 hours. They gave her $26.25. How much did she make per hour? So when I see per hour or per anything, I always think of unit rates, like what we did in the first unit. So I really want to know what is per 1 hour. We know that she received $26.25 per 3.5 hours. And so if I thought of it as a unit rate, I would know to divide by 3.5. Which is something that we talked about. Now we're just putting decimals in the mix. So really, if she made a certain amount of money, you divide that by how much time that she worked for, you can figure out how much she worked per one. And so that's what we're really going to do. You may think of it as a unit rate, or you may just think of it as, well, she made $26.25, and that took her 3.5 hours. We need to figure out how much it took for 1 hour. So really, we're thinking of it as a fraction or as a long division problem. If we use our estimation skills and we rounded this to about 4 and we rounded this to about 28, looks like it's going to be about $7 every hour. So let's just find out. We should have an answer close to 7. So it looks like choice B or choice C would probably be if I was guessing, what I would try to guess at. Let's multiply that by 10. Multiply this by 10. Now my decimal place is going to go there, and I know that for sure. How many times is 35 going to 262? Well, I know that 35 times 10 is 350. I think we're going to have to do 35 times 7. I think that was correct. 245. And we bring the next number down. 175. That is a good number because I know that that will go into 175. Again, if you remember that 35 times 10 is 350, exactly half of that will be 175. So estimation all over the place in these problems. No remainder. So it looks like she's making $7.50 per hour. When we talk about currency, we go to the hundredths place because we know there are 100 cents in a dollar. So even though we got 7.5, $7.50 is equivalent to 7.5 as well. So look at each expression. Is it equivalent to 34.7 times 2.03, or 34 7/10 multiplied by 2 3/100? Select yes or no for expressions A through E. So let's try to figure this out here. I'm going to say that what they're doing on some of these is just like in this case, they're just moving the decimal from the original problem. And I'm not sure what they did here, but we can check. Again, they're moving the decimal. In this one, they move the decimal here, but not here. And on this one, they're adding instead of multiplying. So let's check what we're trying to shoot for here. 34 7/10 multiplied by 2 3/10. Let's figure out what that product is, and then we can have a better chance at solving A, B, C, D, and E. Okay, that was at the end, so I started here. Now I'm going to move one spot in, so I'm going to start right here. Okay, now I'm going to move another spot in, so I'm going to start right here. I'm going to add up. Not sure why I underlined that and didn't actually start there. Sorry about that. When I add these all up, if you want to put the placeholders in there, that's fine as well. These are the partial sums. We talked about how the area model is related to this as well. It looks like we got 70441. And when I'm taking 35 by 2, that should be around 70. So I know the decimal goes there using my estimation skills. I can also count 1, 2 there, and 1 there makes 3 altogether. 1, 2, 3. So we're shooting for a product of 70 and 441 thousandths. So I can multiply these all together to figure out which ones match 70 and 441 thousandths. Some of them are addition. Keep in mind, like for, I guess what I should say is this. Instead of multiplying all the way through on some of these, what I would do is this. I see there are 1, 2, 3 decimals here, and I see that there is 1, 2, 3 here. And if I did this the same way with the same numbers, it wouldn't change, and I would still move the decimal 3 spots, so I would know that is a yes. If you're not convinced, you could always multiply it out to figure that out. This one, again, we have the same exact numbers. We have 1, 2, 3. 3 spots behind the decimal. We don't need to count that spot because 0.0 is really not necessary in this case, so that would definitely be a yes. They're the same exact numbers, 3, 4, and 7, 2, 0, and 3, and there's the same exact number of decimal places, so yes, they would definitely have the same product. I think that's kind of what they're trying to make you realize. In this case, I have the same exact numbers, but we have a different number of decimals. We have 1, 2, 3, 4, so I would know right away that's a no. Let's take a look at these addition problems. 34 and 7/10 plus 20 and 3/10. I can see already that's going to end in a 0, so that's not going to be a good deal. 55, which is not the same. And so that's a no-go. And then 34 and 7/10 plus 35 and 741. 1, 4. So we're on the right track. 4, 0, 7. Boom, that one did add up to the correct answer. So there we go. Make sure when you're adding, you are keeping the decimal aligned in the right spot. Finally, it says that one of Mr. Edwards' students answered the following problem on her homework. 17.06 multiplied by 25.1 equals 42.8206. Explain to Mr. Edwards whether or not the student got the question correct and explain why. So then it says to show your work. So I can work this one out if you would like, and I'll point out all the mistakes that I see students make sometimes. If I take 17 and 6/100 multiplied by 21 and 1/10, sorry, 25 and 1/10, start at the end, so I'm going to start at the end here. So 6, 0, 7, 1. All right, then I start, oops, I'm going to start at second number in, so I'm going to start writing my numbers right here. 0, carry the 3, 3, 5, 3, 8. Okay. And then I'm going to go to the next number in, so that's where I'm going to start writing these numbers. 2, 1, 4, 3. And you can see that I'm aligned pretty well with what we have over here, which is what it's showing the same thing as. Now if I add these up together, I can put my placeholder zeros in. 6, 0, 12, carry the 1, 5, 6, 7, 8, 12, 1, 4. Okay. So in this case it was multiplication. I see 1 here and I see 2 here. Together that makes 3 total places. Right there. 428 and 206 thousandths. So it looks like one of Mr. Edwards' students did a really good job multiplying, but unfortunately the only difference between our answer and their answer is that the decimal place is in a different spot. So that student probably didn't use estimation to make sure her answer was accurate. But you can see that it explains in the book for part A that, yeah, she moved her decimal places too many times. She should have only moved it 3 times. And so when we found the answer, that's what it should be. And that's it for today for your independent practice answer key. So hopefully you are well prepared for your quiz and you do a nice job.